Page 192, number 51, y equals natural log of x in parentheses. Looks like that whole expression is taken to the square root of x power. Interesting. All right. So, I mentioned this in a video from the day before, but what we're looking at here is very different from what I'm writing right now. Okay, those two things are very different. In the first one, the entire natural log expression is being taken to that exponent. The one over here in the corner, that exponent only belongs to this x. And so it's only this one where you are allowed, by rules of logarithms, to bring that exponent forward. Okay, on this one you cannot. It's not a rule of logarithms. Okay, so because we have this log in parentheses, it's a different situation. But we still have a variable in an exponent, and so the way to do with that is logarithmic differentiation, and so we're going to take the natural log of both sides. So the natural log of y, and then I'm going to take the natural log of all this stuff right here, natural log of x to the square root of x power. Okay. Now I have the situation that I was talking about, okay? This is the situation where we're allowed to use our rules of logarithms. I have the natural log of this thing right here, okay? And because that thing right there has an exponent, the rules of logs say you can bring that exponent forward, okay? And so when we bring that forward, we get the square root of x, natural log of the natural log of x. Okay, so it's the natural log of, and then this thing right here is kind of like your angle, if you think of it in trig terms. Not that it is, but okay, so it's the natural log of the natural log of x. That's what we have on that side. We still just have the natural log of y on the left side. And we got to, oh, you know what? Let me take care of this. We got to write that as x to the 1/2 power times the natural log of the natural log of x. Okay. Product rule is what we're going to do, because now it's time to take the derivative of both sides. The derivative of the left is 1 over y dy. The derivative on the right, I got product rule going on. Okay, so the derivative of the first expression is 1/2 x to the negative 1/2 times the second expression plus the derivative of the second expression. Okay, so I have the derivative of a natural log. It is 1 over whatever you had in parentheses. So I have 1 over the natural log of x times the derivative of what's inside. And what's inside is the natural log of x. The derivative of that is 1 over x times the derivative of that x, which is just 1. Okay, all that is the derivative of the second expression, and then I have to multiply it times the first, which is x to the 1/2 power. So you got a lot of cleanup going on. I gotta write that better. Okay. All right. So over here we have our 1 over y dy. Let's see, what do we have here? We have the natural log of the natural log of x on top. It looks like we have the 2 and the square root of x on bottom. I'm going to go ahead and write that back as a square root. My x to the 1/2 power. Because you had a negative exponent, it moves below. Okay, that's what we have there. Plus, let's see, I've got x to the 1/2 on top. On the bottom, I have an x and a natural log of x on the bottom. Okay, I can cancel those two x's. So again, you're subtracting exponents, right? 1/2 minus 1 gives me negative 1/2. So when I rewrite that, that x to the 1/2 cancels with this x to the first, and I end up with x to the negative 1/2, which means that x to the 1/2 power stays on the bottom. The natural log doesn't go anywhere. Okay, I'm just going to write this other fraction down there. I'm going to go ahead and rewrite that second fraction. Plus 1 over the square root of x times the natural log of x. Okay, that's what we have. Then you want dy by itself, so multiply both sides of the equal sign times y. Okay, that'll cancel that over here. So this whole expression is times y, And because we want everything in terms of x's, you go back to the very beginning. I don't remember what the beginning was. It won't let me scroll down. So basically, in the very beginning of the problem, it identifies y for you. So I have the natural log of x over 2 square root of x plus 1 over square root of x natural log of x times y, which in the very beginning it said was equal to the natural log of x taken to the square root of x power. Distributing that is not really going to help you at all. You can just leave it like this. That's your derivative of y. Is all this chunky stuff right there. If you decide you want to simplify further, again, sometimes the book does, sometimes it doesn't, sometimes we will, sometimes we won't. I don't know, but I did quickly, I kind of stopped the video, looked in the back of the book to see how they left it, and they simplified these two fractions. So again, I don't know why sometimes they get a common denominator and combine, and sometimes they don't. But I'm going to show you how they got what's in the back of the book. If you have what's here circled, then that's great. What they did is get a common denominator. Okay, so every expression here gets included in the denominator. So a denominator in common is going to include the 2, the square root of x, and the natural log of x. All three pieces have to be part of the common denominator. 2, square root of x, and natural log of x. Okay, so the first fraction, the only thing missing is the natural log of x. So you multiply top and bottom by the natural log of x, and you get natural log of x times the natural log of x. Okay, I'm so tired of saying natural log of x. All right, the second fraction, you have the square root of x, you have the natural log, you're missing the 2. So you multiply top and bottom by 2, and you get 2 times the square root of x times natural log of x. Okay, all of that is being multiplied over here times the natural log of x in parentheses to the square root of x power. And now that you have the same denominator, you combine the two, natural log of x times natural log of x plus 2, all that over your common denominator, and all that is times the natural log of x taken to the square root of x power. That's what the book has. So all they did is one step more than us, combine, get a common denominator. So that's how they got what they got.